Okay. Welcome, everyone. Thanks for making time today. I'm Shirin and will guide us through the next minutes. We are delighted to welcome Dr. Georgios Kapogiannis from University of Warwick, who will be sharing insights on navigating uncertainties in the built environment, the role of intelligence and digital twins in driving strategic resilience. Thank you for joining us, and the floor is yours.
Thank you so much for this kind invitation. For me, that means a lot because I'm here not only just to disseminate knowledge as we're supposed to do within the universities, but mainly it's about sharing and learning from each other. So please, that's why I do need your valuable input as well during this discussion. So the learning outputs of this session is mainly to understand better about the uncertainties in the built environment, to go through the role of intelligence and digital twins, and aiming at the end of the day to understand a better pathway towards driving strategic resilience. So the way I see seven dimension actually is in the eye of sustainability that is not only isolated but directly influenced by 3D, 4D, 5D and 6D. As a matter of fact, we don't see a lot of work, even reporting wise from professional bodies about the sixth dimension, which is really critical, and we pass by and we go straight to the 7D, which is about the sustainability. So in this way, I am afraid we really ignore the sustainability uncertainties that can really undermine the overall project performance and resilience. And this is a key aspect of how things could be better be prevented. So uncertainty, the way I see that, is mainly a central challenge. That is not only economic, social, and environmental conditions that are dynamic and unpredictable, but mainly when it comes with the context of a project planning. In particular, it could assume the stability which creates performance vulnerabilities when condition changes. For example, climate change, market volatility, regulatory shifts, even what happened with COVID-19, and God knows what might come later. So are we ready really to accommodate that? So in the study that I conducted years back, what I find out interestingly enough is that if I use a pestless analysis, then I should be able better to understand, as a matter of fact, how these risks could be really generated and what dimensions might be impacted on. So for example, I see, excuse me, inflation, taxation changes, unstable cash flow to have an impact on the 50, 5D, and 60. The social, demographic shifts, labor skill shortages, and cultural attitudes towards the 3D design. The technological goes 4D in terms of the time, despite the intellectual property issues and unequal access to digital tools, all the way to the 6D procurement. Legislation is a big thing that we miss that a lot. That means you might have changes in the building code. However, we have contract disputes, procurement law reforms, and that has an impact on the 5D and the 6th and the 4th D. However, environmental still things are ongoing in terms of carbon emissions, life cycle, energy performance, sustainability, compliance. So in this study, what we identified was the interconnectedness of uncertainties. However, in particular, under the assumption we mentioned before. So let's see here, this is the study that was published years ago. So on the left-hand side, in the figure one, we can see the economic, the social, and the environmental elements, and beneath we can see actually the abbreviations into it on how each dimension goes within sustainability aspects. And in particular, looking at the production and the resources, the exchange and the transfer, the technology and infrastructure, the materials and energy, the communication and critique, law, justice, emission, waste, organizational and governance, build, form and transport, and so on and so forth. So this interrelationship, what showed us, it was much better and more clear on how we could really go from the uncertainties towards assumption. And that happens because I can create hypotheses that are based to known unknowns. So to do that, what we had to do, as a matter of fact, was really to map the project information, the whole life cycle asset during the design process. So the link could really help us was the unified modeling language, or also we can call it really IML as in terms of the life cycle management. Now, unified modeling language really help us to map and to understand the whole process and how this journey can take us. So, and this is the innovation that might derives from when we link UML and building information modeling. For your records, I'm coming from a background in information systems and applied informatics in particular, with MSc in management economics of telecommunication networks, despite my PhD is in construction project management. And that really influenced and inspired me on how really to go through this shift in stakeholder mindset. So on this basis, by pre-identifying the uncertainties, encourages a proactive culture among the stakeholders by reducing reactionary behaviors and project risks. And we did a preliminary study with a company in Portsmouth, where they told us, as a matter of fact, that this could be a way forward, but the problem is whether companies do have this mindset in place in order to move towards this direction. Now, involving end users through the participatory tools can really improve resilience and ensure projects to meet community sustainable needs could be a case. However, what we don't know, or what we learned as a matter of fact in this research, is how we could link the uncertainty to the BIM's 7D sustainability by using the pestle analysis. This systematic approach gives us the capacity of becoming more dynamic and interdependent nature of identifying project risks. However, we could argue that embedding uncertainty management in BIM platform can help deliver sustainable projects more efficiently and effectively over the whole life cycle from design to post-occupancy. However, there's a big question. Are we really ready to go through this process? And let's simplify what we said before. So when we were talking about inflation before, unstable cash flow and local resourcing, that means the impact is coming to the proactive planning to reduce the cost overruns and the procurement risks. When we are in a position to get a better understanding of the social elements, for example, what the community needs, the labor skills, and the user behavior, the impact could be a better engagement, so that can help us really to design what can be accepted and suitable and sustainable. Because sustainability is not coming only from the traditional way, but it's coming also the viability of it. The environmental aspect is not coming only from a climate change and emission energy use, but impact mainly to the resilient assets that meet long-term sustainability targets. Technology, we have rapid tech changes in place. So what we need is to see the impact in terms of the simulation of gamification to improve the stakeholder decision making. And this life cycle integration can impact how? By extending and linking better the UML with the life cycle management by ensuring the adaptability and the resilience. And policy, it could be, and governance is about the governments to mandate BIM without uncertainty analysis. We've seen BIM, yes, it's been taken on board based on project with a value of more than £50 million. However, what is happening? Do we do further analysis on it? So there is a risk of policy failure unless 7D as an uncertainty is coming into play a significant role. So what we learn is embedding uncertainty analysis within BIM empowers stakeholders to design and manage buildings that are resilient, adaptive, and aligned with long-term sustainability targets, as well as when we do that, we will be able to remain vulnerable to unexpected economical, social, and environmental shifts, leading to higher costs, delays, and reduced sustainability performance. So, at the end of the day, we are not able to go where we want to go. So, On this basis now, it has to be highlighted that this study is largely conceptual and based on secondary data, and it lacks really on empirical validation. However, there is an opportunity to go through to understand better with real projects and to develop this integrated to develop it within integrated BIM platforms for uncertainty mapping and to validate how the simulation gamification technologies can really support sustainable design decisions. However, this study took place in 2013, 2014. Okay, that means nearly 10 years ago. Where are we up to now? Can really see what is happening with digital twins and however with artificial intelligence. So digital twins is a real-time digital replica of a physical asset system or process that continuously updates using live data. So that means it's like a sum up of digital twins to extend BIM beyond design into operational lifecycle management of what we called before IML. So now they allow continuous uncertainty management instead of static predictions. So adding this to the bridging use of performance gaps by showing how assets really behave under these conditions, it could be an amazing scenario. Because this scenario is a what-if scenario that could help us to make predictions. On the other side, artificial intelligence is here to help us to teach about patterns from data, historical and live data, and to predict and optimize outcomes. So AI can detect, classify, predict uncertainties earlier than humans in principle. However, it works with digital twins nicely to create these autonomous decision support systems. So we move to a more adaptive, as a matter of fact, environment. So it can enhance the gamification of the simulation by making scenario modeling more realistic and personalized, and however to support the policy. So that means we don't go to the risk that was highlighted before. And according to the UK government definition, AI refers to products and services that are adaptable and autonomous. In this occasion, are we talking about adaptability and adaptive management? That's a very good question, but let's see if that comes later. So if we would like, therefore, to represent from a mathematical perspective, we have definitely a data-driven ecosystem, but this is not something new. What is new here is that the framework for structured data and sustainability modeling can feed into the digital twins as a live operational extension of BIM across the life cycle, and with support of artificial intelligence, then this intelligence layer mines uncertainty data, optimizes decision, and automatically can provide better responses. So this trigon, what we can see here, this stack of 3 different layers, without digital twins and AI, then BIM still remains to be static, and we don't want this. BIM as information modeling, now we have the digital twins, its extension, it has to be more capable of learning, adapting, and self-optimizing against the economic, social, environmental, and technological uncertainties. So, as a matter of fact, by layering building information modeling, digital twins, and artificial intelligence, we are in a position of unlocking adaptive management, which is a term that we have forgotten that completely. So that means that it can help turning the projects into a living system that learn, adapt, and optimize in response to uncertainty. Okay, and this is coming as an assumption based on the literature review. And if we see this from a realistic perspective, what's happening in the projects, we see project management from a pure pragmatic and realistic perspective, but we forget really how to become more adaptive. So the visual before illustrates this progression from BIM 3D to 7D to a more dynamic and multi-dimensional project data through the digital twin, where real-time monitoring bridges design time with live operations. So building on this, artificial intelligence converts vast data-rich inputs into insights-rich outputs through predictive analytics, optimization, and continuous learning. So at the top, adaptive management integrates these insights beautifully into responsive, sustainable, and resilient decision-making, creating a self-adjusting system. So external uncertainties in this occasion, economic, social, technological, environmental, and legislative fit into the model with feedback loops between the AI and digital twins, ensuring optimization and adaptation. And this is what we call the evolution from BIM to digital twin powered by AI, leading to adaptive management and henceforth to respond as to dynamically to these uncertainties. So this new approach goes to learn by doing, continuous monitoring and feedback loops, flexibility and responsiveness, stakeholder participation, and resilience oriented. You might stay here, you might argue saying, oh, George, you are very romantic. People are busy. How can they do that? Trust me, because everything is dynamic, the system automatically really can go through this process and thinking, checking, and reviewing the situation. And the market here tell us within 2025 terms that AI is the only way forward. So if we don't take this on board to help us by preventing these uncertainties and converting those to assumptions, then is completely losing the game. Okay, so to me, this interpreted like having spaghetti without Parmesan cheese. It's impossible. It has to be a living system where, in this context, adaptive management can help to turn the projects into living systems. So allowing learn, adapt, and self-optimize throughout the life cycle. And if we go back to the literature review, adaptive management is a systematic process of monitoring, learning, and adjusting to improve outcomes under uncertainty. So that means there is quite good room to support the hierarchy of human understanding, because humans are thinking based on data and the system is based thinking on the same way. We replicate that, collect data, process the data, store the data, isn't it? And then producing information, where this information we don't know whether we know is right or wrong. So we have to go through the dialogue. This dialogic approach will help us to take the things to a step further. Means making decisions. At the end of the day, this is what I really need to do. And don't forget, as we can see here as per Acrof, the risks are coming mainly from the data level. So if everything is wrong down that level, then everything can go wrong. So in this occasion, data is becoming the new oil. However, information is the refined fuel that is structured by AI for dashboards and reports, and knowledge is becoming the energy now. And this is expensive because AI interprets the patterns and predicts outcomes. So at the end of the day, my decisions will be based on the conjunction of decision making of AI alongside of what is happening into my project, allowing me to be clever. So in this occasion, what do I have? I have a very much dynamic environment that allows adaptivity to happen, assuring visibility of a live operational replica of assets with real-time data. And that goes from Internet of Things, performance life cycle monitoring, all the way through. But the question is this really happening? Well, in principle, yes, that's why we might say that AI and digital twins can really drive strategic resilience. First of all, because with digital twins, we can have live operational visibility, as we stated before, and it helps us really to early detection of risks, transparency, and a dynamic view of the asset health. Second, AI adds prediction optimization to digital twin data, helping us forecasting the scenario analysis. So how does it build resilience? By anticipating the disruptions. Climate cost maintenance, which is quite dynamic anyway by default, and suggest optimal responses. You never get 100% response, but it gives you a range of opportunities of where you have to be and how your decision can help you really. Then we have adaptive management, where iterative cycle of monitoring, learning, and adjusting strategies using AI and DT insights, and that help us to build resilience by enabling continuous adaptation, self-correcting systems, and proactive decision making. My research in the past show that collaborative technologies really can support proactive project managers as long as we have collaborative environments in place. And this is what is happening here as a matter of fact. And finally, the strategic resilience is about the outcome where assets and systems remain sustainable, robust, and future-proof under uncertainty. So projects withstand economic, social, environmental, and technological shocks. So how does this future look like, or is there any future in it? So let me give you now an example of what I did with my team a few years ago back at the University of Nottingham in China, where we designed and developed this beautiful robot. We got two patents out of it. One is for the LiDAR that goes 360 degrees, and the second is about the robot itself. And what it helps me really is to do exactly what we saw before, capturing real-time data using the state-of-the-art technology, the 5G module, have 6G in place, and going through around the space, okay, self-navigated, give us dynamic data. That's why it does also dynamic scanning. Moreover, it has the capacity of static scanning. And finally, semantic segmentation, as well as take on board geospatial data and giving us, as we see, point cloud processing. The video was made by my students. I didn't change it. Whatever is wrong, I don't mind really, because it's a collective piece of work. And it shows us really how we can really be adaptive. So these results now show us not only the tangible evidence of how AI and digital twins could be physically implemented to enhance BIM 7G, but also it bridges the gap between digital models and real-world adaptability, reinforcing the concept of living, learning, built environment systems. So we have the robotic prototype, we have the AI integration, and the potential of adaptive management. Why? Because it can mirror how built environment systems must continuously adapt under economic, social, technological, and environmental pressures, reinforcing the layer of BIM, digital twin, AI, and adaptive model. So here we can see some more details about the foundation of it. And at this stage, I would like to stop, the presentation and to go through a discussion as I earlier stated. Thank you so much. And
Thank you
I'm
so
ready
much,
to
Georgios. Yeah.
welcome questions, thoughts, and exploring more on it. And you allow me to take my notebook as well.
Thank you so much. That was very insightful. Yeah, we will now open the floor for questions. Please unmute your microphones in case you have any question. I think Stefano has a question.
Indeed, Shirin, you know me.
Yes, of course. Yeah, please.
So
Yeah.
what I'm really wondering is, how do you see effectively intelligence-led decision making, as you describe it, evolving at different scales? Because built environment, is managed as an asset at different levels. Like you can think about the strategic network as the entire infrastructure, or you can think about pieces of the network, right? Specific individual asset. How is this kind of across scales decision making going to happen, and what role uncertainty has got in it? Because again, as you change scale and resolution, the uncertainty changes, because you can be very confident about a specific asset, but as soon as you put that in context,
exactly,
right?
This is becoming more difficult. This is becoming more complex. And you have to create a platform, an ecosystem, an intelligent ecosystem that can make simultaneous calculations. So when I was in China, because I used to work as the head of thought leadership for Glodon, I think in Chinese is Gulianda, if I said that correct. It was something that was asked by the clients, really. So it's not about only a building, But what is happening when we have many buildings, many different assets, and different environmental and non-environmental phenomena? How can we pre-identify these uncertainties? And what we told them is that depends what your input is. It's not what we can do for you in terms of designing the solution. So it's going back to the end product and what do they really want to see? What do they expect? And the answer is always, I don't know. What I know, what I need to know is I need to make decisions, as you said. So the intelligence in this occasion, for me personally, is not coming down to the human element, to the tech element. It's coming down to the human side of it. And we should never allow systems, to take the role of decision support systems or intelligent decision support systems, but it should be with the humans. I don't know if I have answered your question.
It's a very complex area, and
it's a very complex question. Exactly, it's just a trying to put down by myself from a pure commercial perspective here rather than scientific-ish to put it.
Thank you,
because
Georgios. And
I understand one thing.
Yeah.
Without the human input, intelligence, artificial intelligence, you name it, cannot be there. We should coexist.
Absolutely. Everything is use case led. And what I can see in my own small point of view from the National Mapping Agency at Ordnance Survey is that we are kind of good at assessing uncertainty at the individual feature level. So let's say a building, right, or a section of road. As soon as you aggregate that at a different scale, different resolution, effectively there is an error propagation effect, and that might, bring some unexpected consequences on whoever wants to use the data that have been scaled up, right? That might not be something that we can predict. Very difficult to model that. So yeah, I was wondering if there was any kind of, effectively a bit of a sounding board for the frustration that I got capturing uncertainty
from a practical
in my own
perspective.
job.
Yeah, from a practical perspective, robots could be a way to do that, to help us. Because the robots can go around and can capture us enough data that we can visualize, to important information that can help us to get better understanding. But are we ready to do that? So we designed the robot and we find out it could do in one asset, as you said, correct. Can we do that in many different buildings and simultaneously to gather the data? Now, what we try to do, because your question is that's very interesting. Now, I start thinking of, we have another project by using CCTV cameras as an alternative way to do that. So with another university, Idaho State University in the US. So our first model shows that it could be possible, but now we want to bring it here at Warwick so we can do some studies within the civil engineering domain. But this is work in progress. We cannot say nothing yet on these regards, because it depends on the quality, of course, of the camera, how you analyze the data, and what algorithms do you have on the backside. We have, of course, some algorithms doing this job for us, but more are coming.
Thank you.
Good point. Thank you. Thank you. Thank you. You unlock something now for me. Thank you.
Okay, thank you, Georgios. Thank you, Stefano. And also, Stefano, I think all, or possibly other participants have this question if the slides could be shared or not.
Yeah, I can say that. Yeah, of course.
Okay, thank you. Stiang, I think you have a question.
Yes, so also a big thank you from my side. Very impressive. Can you hear me, right?
Yes, very well.
Okay.
Very good.
So maybe I have a more general question. So you talked a lot about the uncertainty, but I'm wondering how you define the conception of uncertainty. Is from a more quantitative perspective, like how we measure it, or from a more qualitative way, like how we feel it or how we analyze this, because this is one of my major concern. So people working on the uncertainty, we are thinking about the uncertainty in the different way. And what's your idea to interpret the uncertainty and how to describe it is my main question. Thank you so
Very
much.
good question. I had this conversation when I had my job interview at Andrew University years ago. And apparently we had the same discussion with my peers here at work 2 days ago. And they would keep telling me, George, AI is about quantitative, it's about numbers. And I told them, no, I'm completely against that. Why? How much can you predict by having on board only numbers? How accurate can you be? If we say that from a pure research perspective, it's impossible. That's why we have the triangulation, isn't it? So you need to have back-to-back in place. Now, getting on board qualitative data, okay, that gives you the assurance because you hear people's opinion. And that goes back to Stefano's point, it's a larger scale. So how are you going to do that? Definitely, you need both quantitative and qualitative. In nowadays, Gen AI is being booming like this. Okay, and that has a huge impact to our day-to-day life. How to write and email, very basic things. Imagine now, if you create, sorry, Matt, if I do personal for Atkins, but Atkins having its own internal secure AI, wow. But they have to make sure that it's both quantitative and qualitative and can bring all the data together. Can give you much more robust results. Again, never you will be 100% confident because we have this element from statistics perspective, but definitely you will feel more comfortable with what might comes out and with what we can give over to your clients. Because at the end of the day, the client, everything interprets from a pure financial perspective, where in the academia, we try to help businesses and the society to make the life better.
So maybe a small follow-up one. So based on your answer, there is just one idea so coming to my mind. Now we are talking about we should tell the clients so what's how good or how bad the result is. So we call it the uncertainty, which we already stand on the assumption that we know the ground truth or we know the high quality data to be the reference, and then somehow we can compare to the reference.
Perfect.
And then so this is like a chicken or egg problem. So if we already have the ground truth, why not we directly work on the ground truth and then we do not need to use the ground truth and make a lot of efforts to estimate the uncertainty for our new data or for our data sets. So what's your idea about this? If in some cases we do not have the chance to get the ground truth, how can the uncertainty still play a story?
Right. Before I answer your question, let's go to Matt's question, if you don't mind. I want to buy some time to think about it, to be honest. Okay. Yes, Matt.
Yeah, thanks, Georgios. A variety of questions actually. So, the BIM digital twin AI progression, sort of understood. The challenge I have with digital twins is that there's this assumption that they can be made descriptive enough, accurate enough, to be believable. And there seems to be the assumption that it will come in time. Whether or not that's from the built, from the as designed and the structure, if we go through into the as built and then the variations of conditional change throughout its service life, so the often referred to as operated, you've got variations that exist naturally. What we're uncertain about is the behavior of the asset over its life cycle, and is that predictable in some way? And how do we understand that our models that try to characterize that emergent behavior themselves are accurate enough in a way that can be demonstrated such that we can trust the output using the twin. And therein is one of our challenges around what we're uncertain about, is how do you build trust into a twin? And Shirin, you'll have heard me say this many times in the past. Is how actually do we characterize trust in a twin, such that we can then use it and other analytical techniques on the back of it in a way that we have any chance of believing the answer that it gives rise to, or the suggestion that it makes. And I think therein lies my challenge back to you with regard to what you just described to us, is the BIM, and all of the other Ds that come fine, whatever. It's a way of characterizing a thing, and that's fine. If we then make the assumption that a twin is going to be an accurate representation of whatever the asset of interest is, I think that assumption needs to be really robustly challenged, because again, I don't think that we know how to accurately characterize the twin, the model of the asset in all of its peculiarities and all of its emergent behavior as a feature of how it operates. I don't think we've got that to the level that we need it to be to allow us to then apply further techniques on top of that to then use that as a means to optimize or understand or whatever. And the second comment would be, from an industry perspective, industry does not have the structures in place to make what you've just described real, if you want to call it that. So, for example, some community of companies design something. Another community of companies then are responsible for the build of that thing, using the designs that are exchanged, plus variations that occur because they have to occur, because sometimes the designs need to change because of the construction sequencing and what you find on the ground. And then another community of companies might be involved in the through-life operations of the asset itself. And those communities do not share a technology environment, do not share a data environment, because there are commercial reasons why that won't be the case. So the question then becomes, what is the variation on your narrative for the reality of separation within organizations, and how does that play out in terms of, so therefore, what is a realistic target to aim for? And therein lies one of the challenges that we've got, and with the Research Alliance work and the Digital Road to the Future program we've had for the last number of years, is what is the commercial and business reality within which such models would apply? Does that then tailor or challenge our thinking in some way? So there are my two questions. Do we believe that twins are accurate and representative enough? And if we don't, then anything that follows is going to struggle. And what is the reality of business? Because that will absolutely tailor the applicability and the way that it can be used. Simple questions. I think you might want to go back to the previous question if you want time to think about that one.
Yeah, actually, I really enjoy the nature of both questions. So if I go back to you, Ziyang, based on what you said, could you put me your question just in a line?
Sorry, what you mean?
I think it's a good idea. I mean, your question and Matt, very insightful comments could be answered together.
Yeah, can you put me your question in a line?
Okay. You mean put it into the chat, right?
No, I don't mind. We're orally, that's fine.
Oh, so my simple question is just how can we play with the uncertainty when we have no ground truth to compare? Because this is the normal case for.
How can we play with uncertainties?
Mm-hmm.
Yes. When?
And when we do not have the chance to have the ground truth to compare with.
Actually, the question that Xiang raised is a technical question, and
it's a very
and it is a very I mean, could be a new aspect in dealing with uncertainty, and as I know, and it has not been answered, and it has not been that much coped with in even the academic area, let alone industry.
Yeah, and also,
actually, please go on.
Yes, please.
Yeah.
No, please, yeah.
No.
Actually, another participant, Anson, again asked about the BEAM and AI and how unseen risks and uncertainties could be embedded in the BEAM or AI. I think, again, this question could be related to Xiang.
Yes. So let's go one by one. What I can see here clearly, based on the research we've done, it is quite valuable to say the simulation is the way forward. Gamification simulation, because to have a model standing there without using it, honestly, is like you have wasted your money. Now, that goes back to Matt's question about the variations and the variables you mentioned before. Now, again, that goes as per project's requirements, client's requirements. And this is where we need stakeholders to play a significant role into this game and within organizational level, because don't forget, as a matter of fact, we have a project, but we have organizations, companies working towards this target. So on this basis, what we need to be looking at definitely is to see the challenges from a micro and a macro perspective. And many times we sacrifice our businesses in order to be part of a project because we have to, because it is something that can give us the opportunity to go to another market, to generate income, and to keep our sustainable business environment in place, because we don't want to kick out poor people anyway. So we need, therefore, to have a team of people capturing this data and to try to upload and integrate those data within this module in a simulative environment and to play with. And this is the moment where you can make assumptions within an uncertain environment and you could play, but we need to test it. The robot is not only our robot at Nottingham, but I'm sure that you guys, Matt, you have also in Atkins using these technologies, emerging technologies. I'm sure that Stefano or the other guys using similar technologies. The question is, how do we connect the dots so they can help us to move towards this direction? And for me, in nowadays, I think, to the best of my knowledge, as you mentioned before, emerging technologies are in place. We have to maximize what they have to do in order to help us to eliminate the risks. And you mentioned something about the capability. Now, there are some capability maturity models in place in the market about BIM, driven for organizations. And the word I want to put here into place is the maturity level of the model, the maturity level of the organization, the scale, and how this really can help us to drive towards this direction. It's a very economotechnical analysis, which is really interesting. I like this way of thinking. I don't know if I have answered your questions or I got some good ideas with some valuable feedback, or both.
Thank you, Georgios. Also, another question, I think from Stefano, a crystal ball question. What emerging areas of research do you believe are critical for advancing uncertainty modeling in digital twins over the next 5 to 10 years?
So, Georgios, let's test your predictive analytics skills here. So, what are we going to be able to solve in the next kind of short to medium term, not the long term, next 5 to 10 years? It's still a
I think
research,
in this occasion, I don't know if you remember from the Greek mythology, this magic ball in Delphi, where can tell you the future.
So it's time to take yours out, polish a little bit,
Yeah.
and give us an answer here.
You know, for me, I don't definitely believe it is artificial intelligence. No, artificial intelligence for me is just a bubble at the moment. Okay, robotics is going to play a significant role in how we collect data and how can we visualize this data, better visualization of the data. This is what we need, and I think that's why quantum computing is coming to play a significant role in this as well.
Okay. So
Stefano,
let me go one step further then, Georgios. So obviously we live in a world where, especially in digital twins, the technology is sometimes very uncertain, a bit of a mystery, right? But I would say that the kind of geopolitical, the societal one, maybe now are even worse. You know, if in the past we thought that we could have a little bit of a future looking into what might happen, things are moving at such a scale now on the social side that the technical maybe is becoming the less uncertain of the two. So how do you think that an environment like digital twins, Georgios, that inevitably is a socio-technical thing? Because not only about techniques, right? Someone needs to use those and implement stuff, make decisions, use them. How do we manage that?
Stefano, I didn't expect this to happen today. Few days ago, published with my colleague in Greece, a paper talking about how sustainability, security, and technology, they are coming together, and how geopolitics going to play a significant role, because we see that from a military basis. I will be happy, Sirin, to share with this presentation a copy of this paper.
Yes, I know. Yeah. Also, Stefano is actually collaborated or collaborates with RICS, RICS, and he developed and published a report on digital twins from design to handover of constructed assets. I'm sharing currently. If you want, I
Please share
it
this
with
one
you.
as well.
Yeah.
Yes, that's important.
Yes, yes.
We did this. I was a project manager actually when I was working for Piloto.
Yes, I think it is very insightful as well.
Yeah.
For participants.
No, very good point, Stefano. Honestly, I didn't expect that.
Stefano, I'll turn the question around as you would expect me to. So I think we've all got our view as to areas of research that need to advance to make this real. I've got a few thoughts. What would you say would be the areas from your perspective? Any thoughts, Stefano, from you on how to answer your own question?
So Matt, you were asking me. Okay, I thought you were asking Georgios.
Yeah, me too. I was getting confused. I thought, yeah.
So
no, I'd ask you to answer your own. I've got a few ideas myself, but I'm interested in Stefano and your thoughts on how you'd answer your own question.
So the thing is that we already started answering that, and I can share a link with what we create is called the digital cookbook for digital twins. This one is a Euro SDR. So Euro SDR is effectively a group of national mapping agencies, 20 or so members. And what we started capturing is use cases for digital twins, potentially ways to measure how effective a return on the investment for us on the data that digital twins might be needing and using. So we already started thinking about that. I will share a link now with the codebook, Matt. But in essence, if I need to be brutally honest, we still don't know what our role in digital twins is, because I don't see how that technology is being fully adopted by customers. So there's a lot of talking, there's a lot of marketing speak, a lot of business development, but in terms of real, if you like, applications that provide value to customers, I've seen very little things. So we are still exploring what our role is in that. And that might sound a little bit cynical, but at this stage, that's the best that I can give you. basically we don't know. We are trying to figure it out. That's really where we are.
Yeah, it's a tricky one, isn't it? So if I frame this as to what needs to be true for a digital twin to have any chance of performing a role, there's many layers to that, I would suggest. Industry has yet to adopt digital twins in a meaningful manner, in whatever they mean that to be. Fair statement. Industry has used spreadsheets for a long time to be a reflection of how a business operates. We may or may not like it, but some people say that's the digital model of how the business operates. Badly, it is incorrect. It's not the way to do it, but nonetheless, pivot tables are everywhere. My point being is that there's a lot of technology opportunity between a GIS-based mapping-based layered data model, all the way down to how do we simply run our businesses at the moment using spreadsheets in Excel, for example. So there's a lot of ground you can cover in that space. There is no killer app as such, because there is no consistency of need, and there's such a variability. We mentioned maturity, but there's a whole series of things on it. So under the assumption that there's a thing that will ever emerge as a digital twin, or the usable set of technologies that would feed a model of how a business operates to enable the business to decide how to intervene, how to spend, and to delay, or whatever those normal factors when you come to decision making are. That's the digital twin side. From an actual underlying technology side, sensors in the wild, whether or not they're embedded or retrofit, or whether or not you had an image of a robot, an instrumented robot going around an office. Fine, they are what they are. They will come and go through time. There'll be variety. The key component parts that are missing at the moment is the high bandwidth comms to get that data from there to a place of analysis, or edge compute structures that enable us to do the analysis in situ, for example. So where do I analyze? You know what that is? Do we know what the underlying architecture looks like as to who needs to analyze and where? And and what's the timing I've got available to me? So is there a tempo? Is there a network latency issue? Is there a timing issue there? So we haven't really bottomed that one out yet. We haven't got the comms. We don't really have the high performance compute, parallel compute. I'm not going to mention quantum, but some people might. But nonetheless, we don't have the compute structure to enable us to process the volume of data about what describes the behavior of a live asset. And we don't have the compute power at a consumable enough price point for us to actually use it to understand what that emergent behavior is. Okay, so I don't believe the twins. We haven't got the comms. We've got a whole load of technologies that are coming and going to do survey. We don't have the compute power. So we're on a really good starting point at the moment. We've got so many things we just don't understand. And on top of that, we're gonna sprinkle on a bit of AI to automate all of that. And I think what we're really talking about here is we are still in the process of we're trying to put the guardrails around our uncertainties, and we're trying to define our uncertainties. So I think a lot of these technologies are not defining answers. They're making clear where it doesn't currently work, and we'll refine that through time. And I think that as a way to look at it is natural human, like evolutionary behavior. You start off with a model of the world. It's not right. You refine it. You refine it. You refine it, and so on, and you progress forward. And it feels as though what needs to be true for digital twins to play out is what needs to be true for AI to play out, and that is that as human, we need to trust the models that we are using to act on our behalf, and I don't think we are there yet. So I would look at trust, and how do I embed trust into my models? And again,
so it's not technology, it's about social elements. I agree, and this is the bottom line. I'm going to share the other paper with you guys. It's really interesting. Trust, a big thing.
Yeah. Don't forget. We're all humans. Trust is gained over time and is lost in an instant. We can use technology to automate on our behalf, but if the technology does something, produces an output we just don't think is correct, we lose our faith in its use. And I think, and this is where we're at the minute. We've got a lot of promise around the use of such as this, and then we've got the natural human reaction is to I'm not entirely sure that you've convinced me that what your use and your model that describes the behavior is accurate enough for me to believe the answer that has been proposed. So I agree. I don't think this is a technology problem. I don't think this is a sensor problem, a network problem, a comms problem, a compute power. All of those are necessary, but until such time as we all on this call believe that any model we use to characterize a complex system and how it behaves, until we believe what the model tells us, we will not make the progress that we think. And so my like I say, my suggestion, and this is one of the things that we've been doing with the Cambridge team for the last 4 years or so, is how do you characterize trust into a model that's trying to describe the behavior of a complex system? And the answer has been given as being, that's a data quality answer. And my challenge back to that has been, no, that's part of the answer. But if you break this down as the data quality is the numbers, and then the model is the pluses and the minuses, so the sum, if you wish. If we can feed in quality numbers but have the wrong calculation, the answer is wrong. So it's got to be more than just data quality. It's got to be what is the model, and is the model correct? And that's the bit I think that we're missing. And so the digital twin element within, I think this is it's a label that's been banded as a technology solution, but reality is it's a human trust problem, and I don't think we've bottomed that one out yet.
Okay, thank you so much. Yeah, please go on. Yeah,
Matt, you gave a very good statement, and I really like your final statement. Couldn't be anything better than this.
I think
happy to have a chat, Georgios. If you're at Warwick, Georgios, if that's the
Yes.
case, I'm in South Worcestershire, so I'm just down the road. So it'd be lovely to have to meet up at some point and just to talk that through a bit more.
We'd love to.
Yeah.
Amazing. You're in.
Yeah.
Fantastic, Stefan. All of you guys, you are most welcome. To do this conversation here on campus.
yes, great
It
suggestion.
has to be a cross-university initiative.
Yeah.
Serene?
Yeah, across university and also the international, because we have participants from Munich, from Enschede, yeah, and in
Good.
different areas and organization in UK. Thank you so much for your question and for your very insightful discussion. Yeah, different aspects of uncertainty in the viewpoint of model-based uncertainty or data-driven uncertainty has been discussed. Many thanks. If you want to keep the talks going, please stay connected with me via LinkedIn or email. Also, I sent the material to the participants, the material that Georgios shared with me.
And I will send you also the presentation as well as the paper we published a few days ago with my colleague on the security, technology, and sustainability.
Okay, great. Thank you.
Thank you for the opportunity. Very good session. Really loved it.
Many thanks. Yeah, for support this initiative, and I definitely will invite other also lecturer, professors, yeah, also from industry, from academy, to this initiative to share their idea in the uncertainty in different aspects, and to establish collaboration, interdisciplinary and in different areas. Thank you so much for your time and for your actually attention. And I will share this presentation also on my YouTube channel. Okay, if there is no comments and question, let me close this session.
So
Thank
we'll
you so
close
much.
with Matt. So in science we trust, guys. I mean, that's what we can summarize this 1 hour. Thank you all.
Yeah, thank you so much.
Thank you very much. Thank you.
This
is
yeah.
Thank you, Georgios. Thank you for that. Good
Thank
to
you.
see you.
Yeah.
Thanks,
Have a
Georgios.
nice day. Bye-bye.
Bye.